Hello everyone. We are going to present a presentation about the redesigning of Scotch yoke mechanism to be used to drive two reciprocating pumps. First, let us start with an abstract. For the abstract of this project, the Scotch yoke, also known as the slotted link mechanism, is a reciprocating motion mechanism, uh, converting the linear motion of the slider into uh, rotational motion or vice versa. The piston or the other reciprocating part is directly coupled to a sliding yoke with a slot that engages a pin on the rotating part. The location of the piston versus the time is simple harmonic motion, which means a sine wave having constant amplitude and constant frequency given at a constant rotational speed. So as for the introduction of the 3D modeling, the three-dimensional representation of any objects or surface using a computer graphics tool is known as 3D modeling. As we already know, 3D modeling is used in different kinds of industry for the simulation, for the animation, and for the analytical manipulation. The 3D modeling can be said to be one of the most abundantly used tools by engineers, the architects, filmmakers, game developers, and other professionals, which requires a graphical representation of any object. Therefore, 3D modeling has a wide range of applications in the field of the gaming, the filmmaking and television, development of the product design for the industrial use, uh, building different kind of architectures, manufacturing of different kind of projects, and it is also used in aerospace engineering. Moving on, let me give you a brief introduction about the Fusion 360. As Fusion 360 is a cloud-based 3D modeling, computer-aided design, or computer-aided manufacturing software platform for the product design and manufacturing. Design and it is a software used for the design and engineer products to ensure its aesthetics, form, feed, and functions. Uh, the Fusion 360 reduces the impact of design, engineering, and other changes, which ensures manufacturability with simulation and generative design tools. The Fusion 360 has different kinds of tools in it, and which helps in turn of making various kind of simulation and 3D design very easy. So the scope of this project requires the Autodesk Fusion 360 for the 3D modeling of different components for the Scotch yoke mechanism, which is used to drive two reciprocating pumps. Moving on, let me tell you about the applications and advantages of Scotch yoke mechanism. So for the application, this setup is most commonly used in control valve actuators in high pressure oil and gas pipelines. Although the not a common networking machine nowadays. Crude shapes can use Scotch yolks. Almost all those use a Whitworth linkage, which gives a slow speed forward cutting stroke and a faster return. The Scotch yoke mechanism has also been used in various internal combustion engines such as Borg engines, Cytec engines, and many hot air engines, and also it is used in steam engines. It has wide range of applications. It converts the rotary motion into the linear motion and the linear motion into rotary motion. So also the applications for this mechanism is there is no lateral force used on the piston, and it is also used to perform the cutting, sliding, etc. So moving on, uh, I want to hand over this project to my other group member.
Possible. Hello, good morning, and thank you, Asutosh, for delivering me this opportunity. And now I'll be talking about the problem background of the project. And as my friend earlier mentioned about this mechanism and how this is applied in different fields of manufacturing and industry, so I'll be talking about the problem area that actually kind of motivated us to do this project. So this is all related to this Scotch shock mechanism, as we have been researching about this, and we kind of knew that this mechanism has very little uh, heat loss in the form of friction. I mean to say that the frictional loss is very less in this kind of mechanism, where there is very, like, less interlinkage in between the metal body. So that actually kind of motivated us to do a proper study about this mechanism and how we can extrapolate the knowledge of this in a different areas too. As a student of engineering discipline, and also basically, intrigued by the idea of machine mechanism and all those things, we kind of made our mind to do this project and extrapolate the knowledge in this area of engineering. So after this, I'm going to speak about the component of the Scotch yoke mechanism, and as per our design and as per our requirement, as we have made the design to work with the two reciprocating pump to drive the two reciprocating pump, the mechanism being driven by an electric motor, and the electric motor, uh, the power that comes from the electric motor to the is converted by the mechanism from rotatory to reciprocating by the connecting rod, and which I'll be talking about the component that were really applied and that were used for like all this mechanism conversion and the motion conversion. So let's begin with base. The base is the structural framework of our overall design setup, where we have just two racks. The lower rack consists of electric motor, and the upper rack is the part where we have the larger wheel mounted with the smaller, mounted with the connecting rod and error, and also the two reciprocating pump. And we have this sprocket which is used for meshing the gears and the and to ensure that the motion from one body significantly get transferred to the other. And we have kind of used two large sprocket and a small sprocket. A small sprocket is used at the point where the motion from the motor is transferred to the larger wheel through the belt. We have open belt tangent type, as I have mentioned in my report too. This is the simple open belt tangent mechanism between the larger wheel and the wheel that mounts with the motor, so that the motion from the motor can be transferred to the larger wheel and can be used for operating the mechanism. And as spoken about larger wheel and smaller wheel, they are simply the device that has been used to transfer the motion from rotatory to linear, and then from linear to rotatory, or vice versa. So moving on, we have a component like connecting rod, piston, cylinder, motor clamp, and upper wheel clamp and the lower wheel clamp. So connecting rod, as already specified, is just the component that transfer the rotatory motion from the wheel to the uh, you know uh, reciprocating motion in the piston rod, and that actually drives the reciprocating pump. So piston is the rotary reciprocating component inside the piston cylinder mechanism, or the assembly, which actually drives the reciprocating pump. And will motor clamp are simply the supporter for the motor, which is installed in the lower rack of the base. And the upper wheel clamp is the supporter that provides mechanical support to the larger wheel when it is rotating, and also ensures that the vibration that cause effect on the larger wheel is moderately lessened with the help of the upper wheel clamp. And this is the component that we have used. And coming on to the joints, my other colleague, Mr. Nishar Kharel, is going to explain about it.
We discussed about the objectives, disadvantages, and the applications of stock yoke mechanism. Now I'm going to describe about how we designed the project mechanism in Autodesk Fusion 360. We discussed about the components. Now for the joints, firstly, at the beginning we used a rotary joint which connects the AC motor with a small wheel that is used to drive the belt mechanism. And second, we have used the the rotary motion in the larger wheel and larger sprocket, and also in the belt mechanism. The smaller wheel acts as a driver wheel and the larger wheel acts as a driven wheel where belt is used to convey the motion. After that, the rotary motion in the larger wheel is passed to the reciprocal is passed to the connecting rods by a rotary motion. The connecting rods are then joined to the piston and rotary motion is again used in the joints. Finally, the piston is connected to the cylinder where the transfer motion is required, so a slider motion is given. Also, the cylinder is grounded to avoid the movement of the cylinder in the transverse directions. This is our overall design of the project. We have a motor. We have a motor in the base, which is connected to the larger wheel through a belt, and then to the connecting rod that passes the motion to the piston. And finally, we can have our applications like pumping, cutting, or using or some operations that can be done through the cylinder. This is our animation video. We see that the motor rotates, it in turn rotates the larger wheel, which gives the reciprocating motion to the piston, and finally the output is given to the cylinder. Now, for the design, we have used two methods for improvement of our components. It is designed for manufacture and design for assembly. In design for manufacture, it is basically used to reduce the cost during manufacturing. Like here we have used the plane surface instead of undercut, because if we use the undercut, it increases the machining operations and it becomes difficult to machine, which finally increases the cost. So undercut is avoided in our design. Also, in terms of design for assembly, it is used so as we fit the products components in the product correctly. Like when we use the connecting rod, it is same from the front and the back view, but when we use a triangular groove in the front view, we can denote it as the front part of the assembly. And for the mechanism, we have just created a sample of mechanism by using, we haven't machined the whole components, but we have used only larger wheel in our machining. Firstly, we have used adaptive clearing for rough machining, where 6 mm bull nose in mill is used as tool, which is followed by a 3D parallel machining feature where 6 mm ball and mill is used. And finally, the center hole is created by a drill using 10 mm drill tool. The process is automated in the Fusion 360 and the ANSI code is given by the software. Finally, to conclude this, we can see that the Scotch's mechanism doesn't create lateral force. Actually, it reduces frictions and vibrations and it's easy in construction and application. So, it can be used in control valves in high pressure oil and gas line pipelines, as well as in work engines and many hot air steam engines. Now, to conclude the project, I want to thank my professor Liu and our instructor Acute Canaria for guiding us through the process of the learning Fusion 360 and helping us in various machining and manufacturing processes. These are the reference we used in this process, and thank you. Hope you have got a lot of information about the Scotch's mechanism. Thank you.